So last week we were learning about the hydrocarbons, and we started realising that actually those hydrocarbons have other functional groups tacked onto them usually. What I'm going to show you now is probably the last key reaction of the hydrocarbons, and it only happens with the unsaturated ones. So that's your alkenes and alkynes. And the reason for that is that you're going to add these chemicals together to make a macromolecule. And macro means really, really, really big. Alright? So it's got thousands, millions of these compounds joined together. So they're really, really big. Commonly, you probably think of them as being plastics, and that is exactly what they are. A lot of the plastics that you know are made by getting chemicals that have been derived from crude oil and adding them together, actually taking them on one after the other. I'm going to show you very quickly using a chemical called chloroethane. Alright, so we're going to start with a monomer, so mono 1 mer unit. We're going to start with a single unit that is this. Okay, so it's ethene, 2-carbon alkene, with a chlorine atom tacked onto it as well. So it's what we call chloroethane. The other name that it's often given is vinyl chloride. So you might be able to guess what the polymer is called from that. So it's chloroethane, or its other name is often vinyl chloride. If we were to have lots and lots and lots and lots and lots of these, and heat it, and put in a polymerizing agent, which is basically like a catalyst, then it breaks these up. It actually breaks the double bond, turning them to a thing we call a free radical. So with the heat and a polymerizing agent, and as I say, it's pretty similar in the way it works, is pretty similar to a catalyst. It'll break it up into this. It breaks the double bond, and it's got a lone electron on each side. So this is pretty similar to a Lewis structure. We're showing the lone pair on each side. Now if that comes near another one of these molecules, it'll also break its double bond and create a single bond at the carbon, whichever one is nearer to it. Or it might come across another one of these free radicals and just join together. Either way, the mechanics of the reaction is not important for this yet. What's going to happen is you're going to get lots of these lined up next to each other and end up with if I take a piece of the polymer, a snapshot of a piece of the polymer, it will look like this. I'll put one more carbon inside. And you can see that it keeps repeating itself. It's got in it what we call a repeating unit. So something that keeps looking the same. This keeps looking the same. So we call this a repeating unit. I'm just going to show square brackets around that. Okay. Now in this topic, you need to be able to look at a monomer and work out what it would look like if we took a photograph of 3 of those monomers stuck together. So that's a piece of the polymer showing 3 repeating units. But you also have to be able to look at a section of a polymer and work out what its monomer would have been. If I have a look at the polymer, there's no double bonds in there at all. Okay? No double bonds or anything in this carbon chain or the backbone of it. But if you notice the monomer, it has got a double bond. So in an addition polymer, which are the only ones that we're going to learn about in level 2, you start with an unsaturated one. Now if this did have some double bonds, so when double bond, single bond, double bond, single bond, can anyone guess what the monomer would have between the carbons? Triple bond. Well done. So this is where this works for alkenes and alkynes. But you have to look at the backbone, carbon backbone of our addition polymers or plastics to work out what it would have been. Can anyone guess what this polymer is called? If the monomer is called vinyl chloride? Polyvinyl chloride. Does anyone know what its abbreviation is?
PVC.
PVC. This is a section of PVC. Alright? And it's that chlorine that gives it a lot of its characteristics, physical characteristics. Right, not quite done there. I want to now draw a polymer, and we're going to try and work out what its monomer was. We don't need to name it, because I'm going to draw a really complicated one. But we're going to work out what its monomer would have been. So here we go. So again, I'm going to draw 6 carbons in a row, because that shows me 3 repeating units. Alright? So you'll see in your assessments, this is usually the way it's laid out. 6 carbons in a row like that. Silly, wasn't it, my shortness? Now, I've done a bit of a trick here, where I've rotated this one so it's sticking up the top. And the reason I've done that is actually so that it doesn't get too congested down here. But actually, the repeating unit is just the same. Because this is just single bonds, all of them can be rotated, they can be turned. So anything that's on the bottom can actually be on the top instead if we spin the whole thing around. Alright? So I've done a bit of a trick, I've been a bit nasty. Can we see what's repeating? Can we see what the repeating unit in here is?
Yep.
Okay, so I'm going to take it out of the middle there. So it's C. So CH2, CH, and then that funny thing off the side of it. Oh, very good. So this is my repeating unit. This is what keeps repeating. But the carbons don't have enough bonds. So exactly as was just said then, to give the carbons 4 chemical bonds, I put another bond in between them, and now I have my monomer. So here I've got my polymer, my addition polymer, and from it I've been able to find the monomer. And again, you don't need to name this, okay? That's not necessary in this case. Alright? So that's the main skill that you need to be able to do, is to find the repeating unit, and that was with the single bond, and then work out what the monomer was from it. Alright. As I say, if we double bond, single bond, double bond, single bond, you know that the monomer had a triple bond in it to start with. Right, so that's addition polymers in a nutshell. There's a lot more that you learn about them when you go on to level 3. There's a lot more that happens with these, to do with how to change the density, to do cross-linking between the chains and stuff like that. But for now, it's just an introduction. How do I make them from an alkene or an alkyne? And if I'm told the structure of a polymer, what's its repeating unit, and what, therefore, was the monomer that it was made from?